Hello, and thanks for meeting with us today. We are happy to introduce our work we are doing with the Navy. First, let me introduce myself and the company. I am Tim Hall, the Research Director at Faraday Technology and the PI for this activity. I am supported by Dr. Zach Lawson, who is leading the experimental and design work at Faraday. Dr. Tim Horn of North Carolina State University is leading the university additive manufacturing printing effort. Dr. Brendan Noonan and Dr. Sean Torres are leading RF performance validation and additive manufacturing design transition. Faraday is a small business located just outside of Dayton, Ohio. We've been around for 35 years doing broad range of electrochemical processes and system design. We have a wide patent portfolio focused on electrochemical surface engineering, including plating and polishing, of a wide range of materials and shapes. The patents here highlight our work with additively manufactured components and their internal passages. In the near future, we will be moving to a larger 24,000 square foot facility in Vandalia, Ohio. The Navy has significant maintenance and repair challenges, as well as design limitations with respect to high-powered sensor and weapon systems and their electronic components. In order to maintain operational readiness and reduce downtime, new manufacturing technologies to produce on-demand high-powered electronic structures need to be developed. These electronic structures could be used on missile systems, like Patriot and Sentinel, or high-powered signal transmission, like that addressed by the Navy's Spy-1 mission, or any other high-powered microwave system. The resulting product for the Navy is an on-demand method to rapidly fabricate and deliver high-quality electronic structures that fit directly into the mission need. To that end, we have noted that the current manufacturing base is not able to cost-effectively and rapidly deliver high-value copper components at low part quantities. This limits their ability to service and return to the field-repaired legacy system components, while also limiting their ability to produce complex compact electronic structure designs for next-generation systems. Therefore, Faraday is supporting the Navy and our Dow partners by developing the operational plans to provide on-demand production of made-to-order copper components, with the overarching goal of reducing lead times and production costs, while enabling design flexibility. To achieve this end, Faraday's approach is to combine additive manufacturing and electrochemical surface treatment technologies to enable this on-demand production. As you can see in the image to the right, the conventional manufacturing approach relies on multiple individual components to be fabricated separately, then they need to be brazed or welded together. These seams lead to performance limitation due to vacuum compliance, outgassing, attenuation, and high-frequency operations. Our approach enables a single component to be fabricated by additive manufacturing. Then, as shown below, we finish the internal passage to enable the material and RF performance. Surface finishing of additively manufactured electronic structures is required to achieve the RF performance, to reduce outgassing and improve vacuum compatibility due to the extreme roughness on the internals of the passage, as well as the low purity of the printed copper metals. This Navy program is focused on designing and developing the method to build, finish, and apply a high-purity coating to those internal passages such that high-quality RF components are produced. Our plan is to achieve TRL 6 on this by the fourth quarter of fiscal year 2027 by building, finishing, and testing a component at the Navy. Currently, we are working to nail down the build and finish parameters such that we can achieve the target S parameter performance and vacuum compatibility. This slide highlights where we are in our current schedule and our current plan to enhance TRL and transition this technology to the Navy and our OEM partners. So, as highlighted earlier, our overall goal is to be able to establish this domestic manufacturing base to be able to rapidly supply copper electronic structure components to the military and OEM partners, leading to rapid replacement/repair of legacy components or fabrication of next-generation structures. The table below highlights several features of this technology and how it creates specific benefits. Once all of the kinks are worked out and the component's performance has been validated, then we can work with our partners to produce demonstration components and parameter methods to transition to the fleet. Outside of electronic structures, this technology could be used for heat exchangers, other RF components, semiconductor manifolds, mirrors, or other things. We are currently looking for partners to identify components, testing metrics, and manufacturing needs, such that we can begin to demonstrate and validate this technological approach to fabricate and finish real components. With these concepts, we are open to exploring a wide variety of applications, and we are open to partnerships and collaborations. Let's collaborate. Thanks for listening to this presentation. Please feel free to reach out.